Good morning, good evening, good afternoon, wherever you're listening from. Thanks so much for joining us today. Just on the chat, let me know where you're tuned in from. And sorry, it's been really a while. We had taken a smaller hiatus, but we are back with our Thursday sessions. We'll be back full program, book reviews, dev stories, deep dives. They'll be back on Thursday. So keep tuning in, same time, Thursdays. You'll find us here. So thanks so much for joining. Today, we are going to review this book called The Rust Programming Language. It's actually available for free. You can buy it or you can get it for free, whichever you like. So it's a welcome. Just housekeeping. Always, I will never stop saying, please. Our goal still remains to get to 1024 subscribers, and then from there, I said I'll never ever ask you to subscribe. Just get us to 1024. We'll take it from there. So if you're new here, welcome. If you've never subscribed to our YouTube channel, please even if you're watching from LinkedIn, just head over to YouTube just for a quick one, and then you can come back. Let me just give you the link here. Just if you search Blackboard or just youtube.com/@blackboard, please subscribe and share with your friends. We like to bring more interesting content as we go. And also, if you like to come and talk about anything, please reach out. Our emails are on our site, board.black. You can reach out if you have a book you like to review, if you like to take guys through some technical stuff, maybe like architectural design of some system you built that you like, that maybe some interesting things that maybe people haven't seen. You're welcome to on board. So this is our platform, it's not just mine. I would like to have more people come and showcase what they're building and what they're working on. It's for enthusiasts, crafters. You're welcome. And Basil, thank you for joining us. For tuning in from Nairobi. Welcome so much. Yeah, so without further ado, I'll just jump right into the review. The book is quite a bulky book. So what I'll do is I'll just try my best to highlight various things from the book. Let me just share my screen real quick. All right. Should I do a slideshow? Okay, let me just do the old school way without the slideshow. Sorry about that if this is a bit distracting. Um, yes, so once again, welcome for this book review. It's the fourth book review. You can go back to our playlist. You could find many other book reviews we've done in the past. The latest was The Pragmatic Programmer by Martha Kabuye, and she did a great job. I'm just trying to see whether I can match that, but uh, I really doubt. She did a very great job, straight to the point, very great summary and, and, and takeaways from the book. So if you missed that, you can check it out. Um, for me today, I wanted just to talk about, look at maybe just three things, just my motivations of why I picked Rust before I got to the book, or why I wanted to learn Rust, and then about the book, a little bit about the book, and then we look into the book review. Uh, just a quick glance of various chapters in the book for you to just have a feel, and then if you think this is a book you like to pick, then you can make your decision. So welcome. So I will. So why Rust? So the biggest, so this is a quote from actually the book. They say, Rust is safe, fast, and productive. Pick three. So most of the times, most languages they rarely have those three things. You can either be maybe safe and productive, but not maybe fast. So for example, C Sharp, Java, fast comparative to things like Rust and C. When it comes to C, it's fast, could be productive. I'm not really sure about that, but it's not safe. And here, safety here is just about memory safety, because those are the biggest number of security hacks happen normally through memory safety issues. So that's what it when we talk about safety. That's it. So there are a number of stories. These are old stories. I think we have maybe newer and better, interesting stories, but just about people who have embraced Rust and seen like tremendous improvement in their, especially security landscape. Google, for example, with Android when from Android 13, they were trying to rewrite some bits from CPP to Rust, and you can see the numbers of memory safety vulnerabilities going down as they keep migrating to Rust. So the biggest actually seller for Rust is usually is memory safety, and then coming with productivity. Of course, productivity is a give and take, but I think it's a language that once you have a grasp of it, you become productive in it. It can have a steep learning curve, but once you have a hang of it, then it's a small thread. So that said, if it's all those three things, why should we care about other languages? If you had something you are building and should you rewrite it to Rust? Of course, the answer is no. Rust is specifically for very niche areas. Of course, people have built many things with it because it's not a general purpose language. But whenever you're considering a rewrite, this is just my opinion. If you had like a number of safety security issues on your code base, and there's a particular module or a particular part of the code base that is always being hit by security issues, and maybe most likely it's done in those memory and safe language like C and CPP, then that's a good candidate of rewriting to Rust. For performance, give and take, uh, languages like C Sharp and Go and others that have a garbage collector, sometimes they maybe same for Go. Go has a good GC that is really performant above the rest, but there, others really have issues with the garbage collector having memory pressure and all that, and therefore hitting on performance. But this is a give and take. You cannot just rewrite the whole code base from C Sharp to Rust just to get performance. There are a number of ways you can have that, and of course productivity just comes along with the other two. Yeah, okay. So let me jump to the book review. So this book review is gonna be an interesting one, um, because I would like to resist the urge of reviewing the language itself other than reviewing the book. So I'm going to review the book about the language, not the language. But sometimes I might end up mentioning some things that I like or stuff like that. But that's just a by the way. But my intention is to review the book about the language, not the language itself. So a quick thing about the book: it is open source, as I gave the link there. Also, the authors were among the core developers of the language. So that's why actually I prefer the book, because this is written by guys who actually were involved in the language. Some of them are still on that project. Others, I think, left, but that is it. And also it's open source, so the book is actually being contributed to by many other people. So that's why also I like the book. But there are many other good books out there that you can pick. So this is not just like this is the only one you can pick, but those are some of my decisions why I picked the book. So this is the chapter breakdown. The book has 20 chapters, as you can see there on the slide. And okay, this I'm reusing some slides that I presented this some time back with a friend of mine, Crispin Chiedo. So he helped me do the chapter 12 is a project. So you do a project at chapter 12 and another project at chapter 20. So that gives you a very good like grasp of what the language does. So that's one other thing I like about the book. So I'll talk to Chiedo. He was actually to join the call. If he joins at some point, I'll add him on the stage. But if due to public demand, if folks would like maybe as another session where we do hands-on, try to build these projects, these two projects, let me know. Just put it on the chat that you'll be interested. I'm still okay with even just two people saying they're interested in that. We can organize that as such a session where we can do a hands-on with you folks. Okay, so in this review, my assumption, a few of my assumptions is that at least my listeners have done maybe a typed language, at least C Sharp, CPP, Go, etc. Even JavaScript now is typed with TypeScript. By the way, it's been long since I left JavaScript when TypeScript was just starting, and so JS is also now sort of a little bit typed. So when you're doing TypeScript, so that's really awesome. So with that, then you can be able to appreciate some things here. And I'll just, as I said, I'll just cover those about five chapters, and just some takeouts from the things that popped out from when I was reading the book. So I'll not cover the whole 20 chapters. There are really many, and also because of time. So I will try and rush through, and stop me if anything is not clear. Be on the chat. Let me know if you have a question. Feel free to put it on the chat. I'll just be looking at the chat, and that would be nice. So let's go. So the book starts with the first chapter with "Hello World." It gets you quickly like your hands dirty on the language a little bit. So the first thing you write is the print "Hello World" as it's been a culture now in programming. So my first impression of when I came across that print line exclamation was one like, why did they choose to put exclamation on a function? So I thought all functions usually have an exclamation. So I said, what is this? So every time you pick a language, like you try to critique it. So by that later on, I learned this is just whenever you say an exclamation, that's a macro. If you're coming from CPP, while or C sharp or C, you know about macros. So this like not really the actual function to be expanded to the specific function that will be called. But functions are just written as fn, the name of the function, as we'll see in the other chapter. So chapter 2 and 3, it covers common concepts, just as many other languages will have. So the thing that popped out for me is the thing about mutability. The language made it that by default everything you declare is immutable. You cannot change it. So if you say let apples be five, you can never say again apples equals to 10. And the error will not happen at runtime. It will happen at compile time, which is really awesome. So the language will catch any issues on your code at compile time. Rarely at runtime. Runtime is just very edge cases issues. And we haven't gone to the good bits about it for yet, about memory now. But this is just building up the idea of memory safetiness, because normally what happens with unsafety is things changing without your intention, or someone pivoting your program to change some things, which is basically just changing memory locations without your knowledge. So already by this already it's trying to bring in that idea of safetiness. Then another thing that also I had never come across was shadowing. So shadowing is this idea of where is it? So we have an example here. Yes. So these are good examples. So you can so look at this. X is 5, right? Let x be 5, and you can say now let x equals to x plus 5 plus 1. So x becomes 6. So this x basically shadows. It actually shadows the previous x. And then also you can actually create a scope, in an inner scope like this, and say let x be x times 2, which will be now 6 times 2, which is 12. And this will only be within this scope. But outside the scope, like here, x is still 5. Sorry, it's still 6 at line 17. So those are some of the funny bit that I found from the language that were interesting. The rest thing, just the same as most other languages, like types. You have scalar types, compound types like tuples and arrays. This is very common. JS people will be happy with this kind of thing. Destructors. You can say tuple this, and then so these are tuple. And then you can destruct a tuple like and extract x, y, z, which is 500, 6.4, and z being 1. So such things, cool stuff. So the rest are what now any language, any modern language will have. So Rust had this, I think, advantage of failures from all other old languages. Like C++ is one of the languages that has really changed over time because of trying to catch up, but also trying to maintain backward compatibility. So it's like C++ is like 20 languages in one language. Okay, let me not throw shit, but it's like at least 5 languages. But because so many things been added over time, but these guys came in late, so just took in good ideas from all other languages and just ran with it. So that's some of the things about the language. Yeah, there is just other concept. What else can I highlight here? This is how you declare a function like hello func. You can declare anywhere. This is of course common with any now modern languages. C, you have to declare somewhere up here the name of the function so that the static analyzer can know that, okay, when you call hello func, it knows it's there. But here you can write your function down here and still call it up here. So this is common with any other languages now, except the old languages. So yeah, so that this another takeaway I got, like first time. So return statement is optional. So when you can write your function. So let's say this function, you could say let x equals to 5 plus 2, and then you just at the end you just put x and it will return that 6. So like here, if you just say 5, it will return 5. You don't have to put the word return, but also return is, you can also add it if you want. You can say return 5, but you have to, now it's a statement, you have to remember to put the semicolon at the end. So, but this is the, so my first intuition, and I saw this, it looked funny. I said, I tried to resist it. Every function I was writing from the book, I was putting my return, like I like my returns being like very clear, explicit. But over time, it started making sense. Like, okay, okay, you see why it's something that just grows on you. So it's a very interesting thing. Yeah, the way used to do math, you do something and then you say the answer there down there. You just say therefore this, and then, basically that was where they're taking that idea from. Uh, yeah, the control flow similar with other languages, if else, same ideas. Of course, this also they borrowed some ideas from Go, where there's no need to put brackets in. Of course, um, also Python, but Python now did not go with the curly brackets, but you don't have to put brackets here if counter equals to 10, stuff like that, just to make few make that a little bit easier on your eyes. Uh, and also, this is an interesting bit that I have not seen in many other languages, where you can say, perhaps this is coming from functional languages. You can put something a loop, and the results of that loop, you return it to a variable, like result equals to loop. So what basically, after this loop is done, the counter um, will be equated to result. That's just some of the things. So, okay, I think in Rust, ownership is the central piece of now what builds up to be memories, the memory safety ideas in Rust. So chapter 4 is the chapter you want to dwell on and really have a good grasp of it. Some things may not make sense at the beginning, but over time, you just try and look at examples, try out things, see how things fail and all that. Um, but maybe another thing I could just mention about ownership, and before I jump into what the book talked about, is you'll appreciate better if you've done any like languages that do you have to manage your own memory, which I think there are really few. Just C and C++ maybe. Which other language? I don't know which other one. Let me know which other languages like you have to do your own memory management, and then C and CPP. So if you've done CPP or C, you'll appreciate this better. But my initial, when I was discussing with some friends of mine, I was saying, I think my idea is that maybe someone needs to learn CPP a little bit first before they do Rust, to just appreciate why Rust. I don't know. I'll leave it open to you. That was my my notion. But over time, I'm learning that learning is, you can learn top down, bottom up. For me, I'm used to bottom up kind of learning, but top down, if top down works for you, that you can learn some things without really understanding where they're coming from, still, and appreciate, that's good. But if you do a little bit of CPP, you'll appreciate better. So let me hear what people have seen some. Jared, how can you suggest someone to learn? Jal, welcome. Hey, can you suggest me some ways to learn advanced development, like one way I thought open source projects, so that what are your thoughts? Yes, yes. Yeah, yeah. So actually, let me do this. At the end, I'll try and repeat so that at the end I do have some tips at the very end of my approach to when I'm picking a language, and then I think I'll add something towards what you've talked about, Jal, what you've asked. But welcome. So ownership is Rust's most unique feature, right? So ownership basically is it enables us to make memory safety guarantees without a GC. This kind of GC garbage collector. So you can be able to all these managed languages like Go, C Sharp, Java, all these have a what you call a garbage collector that manages. So you've done x equals to 10, blah blah blah. You've written your function, right, and they're coming into memory, right? So the garbage collector will look at these values that are in memory and find that okay, this is no longer being used, and from my analysis it will never be used, so it collects those. Of course, I'm just simplifying the explanation, but the many you can go into learning how your GC in your language works, whether it's Go or C Sharp, like generational and all that kind of stuff in CLR and C Sharp. But now Rust, just through mathematical kind of approach of annotation, which you'll see later on, it makes the guarantees that you will not need memory management. It knows that once this variable or this value goes out of scope, it will be cleaned, it will be removed from memory without a GC. So ownership is a set of rules that govern how Rust program manage memory. So it's just a set of rules. Rust has a special annotation called copy trait. So that thing's called traits, and also they have dropped a new term here, trait without. So trait, we'll cover trait at some point at chapter one of the other chapters that we'll go there. But just for now, don't worry about the word trait yet. But basically, they're this what we call traits, and they're just from English words like as I it's called like these are my traits. Basically, you're saying this type is like this. This is how it works. If a type implements a copy trait variable that use it do do not move, but rather are trivially copied, making them still valid after assignment to another variable. So if something has a copy trait, it means if whenever I say let x equals to y, if y has a copy trait, so that value of y the ownership will move will be no, not sorry, I'm sorry, the ownership won't move. That's another trait, move trait, but the ownership will just this will just copy the all the whatever that structure is, copy it to this new location and have now two copies. So of course that's not really performant. You end up having many copies. So like let's look at an example here. So if you say S1 string from hello. But this is how you create a string. And it's again, this is an idea of again types. So basically, this is now creating an actual type from a literal hello, right? So that now S1 owns this hello, this string called hello. So whenever you say let S2 equals to S1, S1 was moved into S2. You see? And now when you say so basically this by default whenever you equate something like this big is moved. Sorry, and as I said initially, copy, but it does not really copy. You have to be explicit with strings. You have to say s2.clone, so it means s1 was moved into s3, but now s3 has a copy of s2. So then let's look at a function like take ownership. So take ownership, whenever you call a function, right, and give it this string, that ownership has now moved to that function. So these are at the beginning they look like very weird rules, but these are the rules that make guarantee for safety. Because if you have you have two functions each taking the same variable, like many other languages will have, you can put the variable in any other function, right? Because it will be either if it's ref for C plus plus, or for other languages it will be just a pass by a pass by value, right? So, but this one is like this text ownership. This function is like a sink. Everything here just look like, for example, if it's water, it goes into this function and it never get back. So whenever you try and say, for example, you print S3 down here, you'll get an error, right? So, and then if say x equals to 20, x will move into a function, but I32 has a copy trait. So it's okay to still use x afterwards. So because I32 has a copy trait. So copy traits are mostly just like, now if you look at these other languages like C++, even C sharp, and you find that what we call primitive types, because they're really easy to work with, they're just like a value, they can just take 64 bits of memory. They're not really complex. And if you copy them over and over, it's not really memory intensive, as opposed to when you have a data structure of a million records. And then if it was a copy trait by default, it will be that whenever you just say y equals to 20, equals to this structure, then you're copying a whole 1 million records, or let's say 10,000 records into another memory location, and therefore that's how we start hitting performance bottlenecks. So most languages, of course, will have a reference. So, and then that's where these rules become very important for ownership. Yeah, so this is the chapter I would like you to dwell on. And again, I've found myself going back to, I'm this kind of person like just teaching. So I found myself going back to trying to cover. So I only want to cover I can't teach you Rust in 1 hour. I wouldn't want to actually go into the details of this. So I'll just mention bits that you can say, okay, let me go look at this. So these are chapter I would like you to look at and see what you can pick from. Yes, and then of course the book also talks about references and borrowing. So a reference is like a pointer. Just if you're coming from even C sharp, it has pointers, or sorry, they call them refs. So there's references. So unlike a pointer, reference is guarantees to point to a value in particular type for the life of that reference. So reference have a guarantee. There's no like things like null references. So that's one of the biggest like sellers that Rust solved. Like when null pointers were invented, which I think who designed null pointers. I think it might be one of the early computer science, either Tony Hoare or Brian Kenigan, who brought it to C. But there's some origin, and actually the author said that was $1 billion mistake that they made, because most of the errors you will see, most of these languages will be like trying to dereference a null reference undefined in JavaScript and stuff like that. So there's nothing like that now in Rust. So all this is just because of this, what quote unquote weird rules that when you encounter at the beginning can make those guarantees. So you can look at that. That's a nice chapter to look into. So I wouldn't want to go into these details. But if you're interested in getting these slides also, I think I'll publish them on a GitHub repo as a PDF. You can just, maybe if you like a quick glance of it. I wanted it to be like a playbook, sort of a tour of Rust book kind of book. But I don't think I can make a good case for just you reading the book itself. And that's just by the way, also Rust stole the idea of playground. I think the first time I saw playgrounds was in Go. So they also have a playground. You can go write your code there without even setting up Rust on your machine. So playground, the URL is, I think, where is it? Just a minute. Yeah, so Rust, let me just put it on the chat. That's a place you can read the book while playing around with stuff there. So play.trustlang.org. So very now it's like every language now has to have a playground. It's like more the 21st century thing. If you don't have a playground, then I think you're not serious. Yeah. So yeah. So I said I won't cover the other bit structs and I'm very. I will say that why I'm not covering was just because of time, but very interesting because especially when it comes to pattern matching in enums, really interesting. I'd like you to go check out. It's very powerful, which now also is in C sharp. I've seen it in C sharp, that kind of pattern matching. But yeah, as I said, when you come, let you can borrow good ideas from other languages. So that's the advantage of Rust now. And then chapter 10 covers generics. Generics are somewhat just the same as same generics that you see in other languages, C sharp, C++, Go. Uh, but just as you know, generics allow us to replace specific types with a placeholder that represent a type, so that you don't know the type at little compile them really. No, you don't know the type whenever you when you're writing, but of course at compile time you have to know the type because you 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 be you be applying that type. The compiler will now replace that type with in your generics. So if you want to do types at runtime, I think it's things to do with reflection. I didn't see reflection stuff on here. I don't remember coming across reflection stuff in Rust, but let me know if you Rust heads here, Rust they call Rustations. Let me know if you have something close to reflections in Rust. But reading the book, I don't remember seeing something like that. Okay, so yeah, chapter 10 covers generics, and generics are just like what other languages do have for generics as my a bit different sort of syntax, but same ideas as you can see from the code example. Yeah, what else can I cover? Define. Yeah, so things like this you can same. I think this is common in the language that do generics. Then yeah, there's an interesting type called which is an option a generic to an option T, and this is some of the things that now allow you to do stuff that are what other languages have things like nullables, right? So so if something has either it can have a value or it can have none. So with this allows you to have so for example result is another. This all these two are defined in the standard in the language itself. Yes, so these options T and RST, they're also using generics, and you can just call option or result, which can have either some value or none. And this is like for results, especially things like IO calls or HTTP that you're not sure about the result and will come. So either you can say, or you can wrap it in an okay if there's a value or an error, if something returns an error after it fails. Yes, traits. Traits, as I mentioned, remember copy traits that we talked about. Now traits are covered in still chapter, that's chapter, sorry, chapter 10 still. So chapter 10 covers generics, traits, and lifetime. So that's also one of the pivotal chapters, I think, also. Uh, because all these are just that idea, extending that idea of memory management. Uh, so trace define, so let's say trace define functionality uh, a particular type has and can share with other types. So this could closely be related to interfaces, right? In these other languages, closely. We can use traits to define shared behavior in an abstract way. So, for example, look at this example on your right. That's from the book also. So there's a trait called summary. So it means like if you if you have a trait summary, you must have a function called summarize that returns a string. Okay. So if you have you create a struct like a news article, which is this is an example of like class in other languages. Also the same as struct in C sharp, also in C++. Uh, of course, I'm not going to the pub. Of course, you can guess public. So you get headline, location, author, content, right? So this is your struct. And then you implement now the function summarize. And then by you say implement summary for news article, right? So news article is a struct. And then you're implementing the trait. So if you implement the trait, you must implement summarize. So summarize, you do your stuff as long as you return a string. So format, this is another macro that just this is just it just string interpolation, right? Just does the same as what you see in other languages. So it means this would be headline by author in brackets, the location of that author. So this is what the format macro is doing. But whatever it is, it's returning a string. And you can see this is where now I started yielding to that idea of okay, return. Okay, you don't need return sometimes. So this is like you see, if just whenever you just the last line in a function, that will be the one that will be returned. So that's how you do return in Rust. But you can put the word return. Like myself, I resisted that for a number of chapters. Then by chapter 10, I think I was sold. I was not using return anymore. So you can see this tweet also implements the trade summary. So traits like interface in other languages. So yeah, look at that chapter. I won't go into other details there. So what else can I just call out? Let me see how I'm doing on time. Okay, time is really going out of hand. So there's and then lifetimes. So lifetimes is those are the new things now. Your lifetimes is like what you've not seen in any language before. New stuff. I don't think. Okay, I do follow languages here and there sometimes, but I haven't seen lifetime idea in any other language. But I might be wrong. Let me know. I don't like saying the wrong things. Just check me if lifetime was actually an idea taken from another language. But lifetime is a pure idea that was for us. So lifetime is another kind of generic. So languages are generic. Rather than ensuring that a type has behavior we want, lifetimes ensure that references are valid as long as we need them to be. So these lifetimes basically basically guide how long a lifetime of a reference will be, right? Which is like a variable, right? How like how long it will stay. And that's how now Rust solves the issue. One of the ways Rust now, like icing on the cake, that solves the issue of memory management, and therefore also memory safety. So when you say let R if this, and then you say let X equals to 5, and then R, you give R a reference to X. So basically R it refers to X inside this scope. When you try to print R here, this code will be wrong. Okay? you'll be referring to something that is not there. In languages that you have to manage memory on your own, like CPP and C, if you do this, it will compile, but it will fail at runtime by null reference. But this one will fail at compile time. That's the biggest point about Rust, that it handles memory issues right at compile time before you ship your code. Nice. So yeah, so that's something I would like you to go look into. I cannot teach you lifetime in 10 seconds, but from the slides you can just see so this like the build up, and then I'll explain the lifetime is that idea of borrow checker. So if you what is happening here is you can we've annotated the lifetime of R with A, right, and the lifetime of X with B. Okay, so this is the lifetime of R. So R stays from here up to here. So just the same as what you see as scope, right? In language, other languages. So this is an inner scope. So meaning X only has this lifetime, right? So when a borrow checker is looking at compile time, it will see this R. You can see R has a longer lifetime than B. So there's no way I'm going to allow you to R to take a reference of X, right? And that's how it just look. It's like mathematics, right? Just checks, and then it's already what was the word here? It's basically it's invalid, right? It is going against the rules. So the lifetime says that R has a lifetime of A, but it refers to memory with a lifetime of B, which is shorter lifetime. The program is rejected because B is shorter than A, right? The subject of reference doesn't live as long as the reference. So, and the lifetime normally is denoted with that apostrophe mark. So whenever you see that, yeah, that's some of the funny bits you see in the language. So this is this one, right? You see this apostrophes. They should not scare you. Basically, they just it's like you do your own memory management. It's like you say, I'm annotating this. This is gonna be the lifetime of this reference, and therefore I'm guaranteeing that it will be safe. Okay, so as I said, I'm sorry, I won't teach the language because I have a tendency to try and teach, but I'm just want to give you about the book so you see the book and then you can go and read the book. So is it just like to sort of whet your appetite, like okay, this Easter I'm gonna jump in the book. Actually, you can read half of the book during Easter actually. Okay, so lifetimes. So it's a long, yeah. I did a number of because of time. I wouldn't finish this stuff. And then chapter 15 is one of the other interesting chapters that I wanted to just a short smart pointers. Same ideas, same name as smart pointers that are in CPP. But a pointer is a general concept of a variable that contains an address in memory. So this address refers to or points at some other data. So this basically a pointer is a memory address, right? And this memory address points to another like location. And then smart pointers are data structures that act like a pointer, but also have additional metadata and capabilities. I think I might have missed a word here, act life. Okay, I think it is act like, sorry. It's K really far from F. How did I make that typo? So they act like a pointer, but also have additional metadata and capabilities. So they're smart. They're like smart, better pointers. So while references only borrow data, in many cases, smart pointers own data they point to. So smart pointers seen so far. So string as you so now voila, you notice that string that you saw in chapter was this chapter 2 and 3, uh, I think 3 is also a smart pointer. Vec also we saw in that chapter, it's also a smart pointer. Both on some memory and allow you to manipulate it. So smart pointers usually implement things like the ref and drop. So the referencing, right? Like those are traits. So like if you're defining your own smart pointer, you have to define those two two traits. Yes, and even I'm running out of battery life, so at the right time. So yeah, that is the now my final thoughts. And then I'll come to what Jai had asked quickly. So I'll say Rust is a good language to learn, just even for this is so what Liosi put it best. I could have played this, but I think I've not set the sound here. Uh, but the way I think about like learning languages, that languages just expand your horizon on how you think about problem solving. So you learning Rust will make you a better CPP programmer or a better Go programmer or Java or JavaScript programmer or learning a functional programming language. The good thing these days, these languages now have copied so many ideas. Like C Sharp has functional programming ideas in it. JavaScript has functional programming ideas in it, but also learning a pure, quote unquote, pure functional language like Haskell or whichever uh, will will broaden your perspective of how you solve problems. So that is just how I think. So even if you say, okay, I'm not a system programmer, why would I care about Rust? I'll just say that learn it for just expanding your horizon, and then you become a better programmer even in your actual language. Uh, yes, and then lastly, no, before I go to this one, I'll just say to Jal Patel, you asked about even you asked a question, but you actually had an answer. The answer was actually what from a question. Uh, yes, you picking up an open source project will help you really learn better because you're learning from best programmers who are contributing in open source, and then sometimes open source can be daunting whenever you're starting any project. You go look for if you go to explore and look for Rust projects, for example, you see so many projects, maybe land on one. It might sound daunting at the beginning, but start small. You can start off by even just looking at contributing to documentation. That's the area that many programmers don't like doing. You do the code, but then documentation is you don't want to like doing that. So if you see there's a gap in documentation, try to document. You start building good rapport with the maintainers, and then now you start contributing to the code base, and then just grow. So as long as you just pick one project that you like, especially one that maybe you use or is close to what you use, it's even much better. And then slowly by slowly, you start making progress in it. Yeah, so yeah, open source, Jal, as you said, open source is the best way to learn hands on. So myself now in 21st century, in 2023, this is how I learn, or 2025. I added a new thing on my learning project, which is ChatGPT. So whenever actually I read, maybe I read a part of the book I don't understand, I ask GPT, okay, explain to me a little bit more about this. So that's now a new thing that I've added. The other two are the other one is just an old way I've been. I like whenever I'm learning something, I always have learn hyphen dash, learn go, learn Rust, learn anything that I've tried to learn, I have a repo for it. So I had a repo for this book, and then I was just writing the code in that repo and then trying to run them, and it was really awesome. So that's how I'll encourage you. You can do that. The other one is just a product shout out. Edge is really good, but I won't go into that. Yeah. So I think that's all for me today. I see I'm right on the dot. uh, any questions, anything before maybe we close? And thanks so much for coming. Thanks, Sebastian. It's good to see you. Long time. Uh, Jal, thank you for joining. Basil. And anyone else? I didn't look at LinkedIn, and I know there are a number of guys at LinkedIn. I'm just looking at what I'm seeing here on the chats. Yeah, thank you for joining, and go have a rusty weekend, and a rusty time. Hope you'll enjoy it. Yeah, thanks. Have a good evening and good weekend. God bless you.